Continuing with value at risk. So, if you remember, I have discussed long time back about omega, delta, vega. So, now you are seeing the real importance of omega, delta, why they are considered in trying to calculate the value of VAR. If you consider linear and non-linear relationship of VAR with these values. So, calculating the change in the portfolio value, hence the volatility of the same is difficult if you have n number of assets, because now finding out the cross VARs becomes difficult, because you will not have any relationship or information about that. As the exact mathematical formulation of the following equation is difficult to find, because as I mentioned, this first part is for the linear part and second part is the second derivative, and obviously there are other terms also which we have omitted them purposefully in our calculations. Now, value of risk has to be found out, that is true. So, how do you find out? So, there is a huge branch of studies in the simulation which is known as Monte Carlo simulation. So, credit for inventing the Monte Carlo method often goes to Stanisław Ulam, a Polish born mathematician who worked for John von Neumann during the Manhattan Project World War II, which is basically the bomb one, the hydrogen bomb or the atom bomb, which basically was discovered by and found out by US. Ulam is primarily known for designing the hydrogen bomb with Edward Teller in 1951. He invented the Monte Carlo method in 1946 while pondering the probabilities of winning a card game for a gamble. The Monte Carlo method, as it understood today, encompasses any techniques or huge set of statistical sampling which is employed to approximate the solutions to a quantitative problem, considering the actual distributions may not be known. Now, to calculate VAR using Monte Carlo method, the very simple following steps are found out. So, what you do is that you find out the value. So, say for example, I will first describe it qualitatively and then come back to the slides. So, what you have is that you have, say for example, the value of the portfolio which is there for you at day 0, considering today's day 0. So, now you consider the change in the overall value of the portfolio, considering the prices are changing. You are not considering the investments are changing, that you can also consider, but that would be the next stage of not complication, but next stage of calculation. So, you consider the alphas or the investments quantums in each and every asset is fixed, only the rate of change of the portfolio is happening, because there is a rate of change on the investments as the prices are changing for the assets. So, now you basically find out the value of the portfolio at time t is equal to 0, and then considering the normal distribution to be true for the overall portfolio, what you do is that you will basically have a multivariate normal distribution. Multivariate normal distribution based on the fact that you know so called weights, because alphas are related to weights. So, you have the weights which are given and which are fixed to you, you find it out. So, from the multivariate normal distribution you generate a number, and basically that generation, that number you will give you the overall change of the portfolio. So, how it is done, let us consider in more lower level. So, consider, if you remember, we had done the Ito's lemma, the Wiener process and the generalized Wiener process. We had considered some alphas, epsilon, and that has a normal distribution with certain mean and certain standard deviation. Consider there are 10 number of assets, each with normal distribution with certain mean and certain standard deviation. So, those means are coming for the rate of change average values, and standard deviations are coming for the standard deviation of the rate of change. So, what you do is that you basically generate each of them individually from that corresponding normal distribution, note down those values. So, once you note down the values, you also have historical the correlation coefficients between the assets, use the correlation coefficients and find out the net rate of change of the total portfolio for day 1, from 0 to day 1. Then what you do is that you increase or decrease your portfolio value by this amount. That means, if your rate of change of the portfolio between day 1 and day 0 is del p, so you add this and find out basically the new rate of the portfolio value. Again you simulate individually at one at a time from the simple univariate normal distribution for the same assets for day 2. Again you already have the correlation coefficient, find out the change of the portfolio and once the change of the portfolio is found out. So, consider this is P1, you find out P2 is equal to del P1. So, this was del P0. So, as you can continue doing it, you have the rate of change of the portfolios and you have the value of the portfolio. Now, as the value of the portfolio is there, there would be different values, it will be positive or negative. So, what you do is that you rank them from the lowest to the highest and find out at what level, that means at what 95% or 90% or 99% level of value of portfolio you want to have such that your VAR characteristics are met. So, this is what you do. Find the value of the portfolio today, that is a Pt is equal to 0, sample once from the multivariate distribution for all the del xi, use the del xi delta xi to determine the market variable at the end of today, that means end of day 0. De-evaluate the portfolio at the end of day, which means find out the value of P is equal to T1 by calculating the change in the value of the individual asset of the portfolios. Now, calculate del P, as I said, find out the del P using the difference between the portfolio value at the beginning of the day such that the changes of the portfolios are given, del P1, del P2, del P3 can be found out. Repeat the steps of 1 to 5, as I said, find out the del P's to build out the probability distributions of del P. Now, what I did not highlight time and again, but I think you must have understood it, that the actual need is not P, it is basically the delta P's which are important, which will give you the distribution of P's and delta P's and also how the VAR is calculated. Because if you remember, whenever you are mentioning delta P, it is basically sigma of delta P, that means the standard deviation, the rate of change of the portfolio. Similarly, if you have done different problems in swaps, in different problems in options, all our concern was the rate of change of the return of the option or rate of change of the return of the portfolio or rate of change of the return of the financial assets, and its standard deviation was more important for us. Repeat steps 1 to 5 many times to build up a probability distribution for delta P. VAR is the approximate fractile of the distribution based on which you are trying to find out what percentage, is it 95%, is it 99%, based on which you will find out the value of VAR. One major disadvantage of Monte Carlo simulation method is that we assume the market variable to be normally distributed, which may not be true. To overcome this problem, we use historical simulation, that means you have the past data and we try to basically do bootstrapping in order to estimate that. In historical simulation, we first create a database consisting of the daily movement of all the market variables over the years and then do the simulation values accordingly. In the first simulation, and when you are doing the historical or on Monte Carlo, in details how you do that. In the first simulation trial, the percentage change in each market variable is assumed to be equal to that of the market variable as in the first day covered in the database in the past historical data. In the second simulation trial, the percentage change in each market variable is assumed to be equal to the market variable as in the second day, then in the third simulation it is as the third day, and so on and so forth. Once you finish that for the nth day, using the information which is there in the n plus 1 step, using the information from each step we find out the delta P, hence the distribution of P, and from the distribution of del P we again calculate the values of VAR as we have done for the actual history this simulation study based on the fact we consider the normal distribution to be true. The main disadvantage of the historical simulation method is there is no stress testing, that means given any untoward incident or extreme cases which are happening, they are not available for us to simulate. No sensitivity analysis can be done, that means rate of change of one variable, how what great effect or less effect does it have on the portfolio value, that cannot be done because we do not have the data. And no back testing can be done in order to basically assume that the model we are using or the historical simulation we are using whether it is right or wrong. Stress testing means this involves testing how well a portfolio performs under some most extreme market conditions in the last 10 or 20 years. Back testing means tests how well VAR estimates would have been performed in the past or historical past is how they would have done in the past or in the coming future, considering the past is the best replica of the future which is going to happen. We could ask the question about how often was the actual 10-day loss greater than 99% in a 10-day VAR. These values, even though they can be calculated in a very simple historical or actual theoretical simulation, they may not be exact true because the overall practical environment is totally different with respect to the Monte Carlo simulation study which you are doing. But having said that, believe me that the overall concept of Monte Carlo simulation, the concept of historical simulation gives us a lot of information how the VAR value is changing. We use a different type of principal component analysis, a statistical multivariate statistical method to handle risk arising from groups of highly correlated assets. Using PCA, which is principal component analysis, we try to define a set of factors that can be taken as a market variables. That means, if you have 10 or 15 different market variables, you want to find out the best 5 or best 6 such that the overall prediction can be done to the maximum possible extent with the least number of variables. So, that is the task of PCA concept which we generally use. And if you remember also in one of the Altman models in the first class when we are discussing the different type of models, Altman models, O score, Z score, zeta scores. So, there Altman did use the concept of PCA in order to solve this type of different rating concepts. Remember, a well known characteristics of the loss distribution is that they have fat tails, as I mentioned. Similarly, for profit distribution also they have fat tails. Fat tails are the extreme sections of the distribution and indicate that large losses, although unlikely because their probabilities remain low, still they have some likelihood to occur that is not negligible or that cannot be neglected. The fatness of the tail refers to non-zero probabilities over the long end of the distribution. Now, remember that for a normal distribution VAR for 2.5 percentage, one tail distribution corresponds to a multiple of losses of values of 1.96. Now, as I mentioned, two tailed and one tail, that is very important. So, you want to only consider on one side of the distribution, considering is skewed distribution in sense. Therefore, if the loss volatility is 100, the unexpected loss will not exceed the upper bound of 196 in more than 2 or 3 cases out of those 100 scenarios, depending if you are trying to do simulation. But if the distribution is not normal, then such simplifications cannot be stated, because non-normal distributions, even if you generate, the probabilities are not as structured or non, they cannot be, even though they can be explained in the form of a functional form like normal distribution. Some extreme value distribution f of x can be given, f of x is the PDF function, but still trying to find out the overall VAR would not basically hold true, because number one, historical simulations cannot be done, number two, doing a simulation considering theoretical one may be difficult, and number three is more important, is that the 4 characteristics we considered, homogeneity and all these things, may not hold true, and for the VAR case may not hold true for the standard deviation case if non-symmetric distributions are considered. So, this is one type of tail we are considering. Basically, this is this, or this can be this. So, I am only considering this fact, which will give you the probability which is overshooting the VAR value. And obviously, again I am repeating, the center of gravity onto the right will give you the conditional value at risk. So, what you have, if you have the normal distribution, you can easily find out using the concept of standard normal, and then you can find out the probability. As mu is 0, hence x is 1.996, which is the percentage of deviation, that is the level of confidence. But remember that for distribution which are not normal, this calculation will not hold true. In case if you have an exponential distribution, then you want to find out the default risk, you have to use this formula. So, the alpha would give you the overall probability, sum of the probabilities, and you have to basically integrate it from 0 to x or from a to x, if say for example, the exponential distribution is starting at a value greater than 0, integrate it and find out the overall area and equate that area in order to find out what is the value of x. X is basically the VAR value which you are talking about. When implementing techniques based on confidence interval and loss percentile, there is a need for common benchmarks, that is these confidence levels are required, or with very high confidence level VAR could be so high that the business transactions soon becomes limited. They cannot, because you have to basically keep aside a huge amount of money as a VAR value. Note, the normal distribution is an approximation for losses in general over a short period of time, but it cannot be applied for credit risks for which the loss distribution is highly asymmetric. In spite of the repeating the same, yet I am still stressing on the fact that the importance of VAR cannot be ruled out even for the case when the distributions are non-normal, because they give you some feel that how the distributions can be utilized in order to find out VAR. Let me give you a very simple example why VAR is important. Like we all solve the Newton's law of motion repeatedly, and we know force is equal to mass into accelerations, and we know that friction is there. Still we neglect friction and solve our problems, and still it gives us very good results. In the same way, VAR has many disadvantages. It cannot be used for other type of distributions which are not normal. Still the concept of VAR in many cases gives us a very good feel that what is the overall risk pertaining to a certain portfolio. So, with this we have covered definitely some portions of the VAR, and considering VAR, this is the end of this course. Even though we may not have been able to cover many of the concepts, but considering the 20 hours we had, we did try in our own best effort, and to give a overall view or optimization, overall view of different type of risk measures, overall view of different type of averaging techniques which are used, then different types of swaps, different type of options, different concepts how they can be done, and we did deal in many of the facts different concept of risk. So, where if you understand the overall emphasis on in all our discussion was that risk is the main important factor in finance and in quantitative finance, which we have to decrease or make it 0. So, I am sure it has been a very exciting class for all of you, and we will be uploading as we do understand that the different type of assignments are being uploaded after each week, and we will have 2 different examinations. The date and the format and everything will be mentioned to all the students on the website, or it will be definitely mentioned through email. So, I would wish all the best of luck, and I am sure that once you go to the slides, once you refer to the different type of references, it will be a good learning process for all of you. And obviously, as I did mention in when I started the class, the whole net has huge set of informations in the area of finance or quantitative finance. So, you have to be on the lookout and gather all the facts such that at least after completing the course, and if you have been able to open up your mind, it will really open up huge amount of knowledge which you have to just pluck and pick in order to understand the concept of quantitative finance. Thank you very much, and I am sure you will do all well in life. Thank you very much.